Caching sounds simple, right? You throw something into memory, you speed up your application, is a quick win, but here's the problem. Caching is simple to start, but extremely painful to get it right. Today, let's talk about why caching is so hard, and let's take a look into the common problems that you will run into and how to deal with them properly. So let's dive in. First, why do we cache? Simple: performance. We don't want to hit the database or an external resource every single request, especially for data that rarely will change. So we use something like .NET iMemory Cache. It's fast, thread safe, built in, and honestly, pretty simple to use. But here's the thing. Caching isn't just about storing data. It's about knowing when the data becomes stale. And trust me, figuring out when and how to invalidate a cache entry, that's the real nightmare. We usually start with a cache aside pattern. We check the cache first, then if the data is there, we return it immediately. If not, we query the database, store the result in the cache, and then return it. It's simple enough, right? And there's beauty in the simplicity. But this simplicity quickly fades when you realize something. What happens when the data changes? So imagine this scenario. Your user will update their profile, but your cache still holds their old profile data. Now your user sees outdated info, and if you have multiple instances of your application running, multiple caches, this problem multiplies so fast. This is called the cache invalidation problem. And yes, it's one of those 2 hard things in computer science, along with naming. So, how do we solve it? There's one straightforward solution. Whenever you update your data, you explicitly remove the cache entry. You remove it from the cache. For example, in our repository, after updating an item, we can call the cache.remove, provide the key to that item that we want to remove. This will force the next request to fetch the data from the database and refresh the cache. It's an easy fix, right? Well, almost, because now every time you write to the database, you must remember to update the cache too. Forget once, and you have got a stale cache again. But wait, there's more complexity here. What if you are caching the entire list of data or complex search results? Now, every time a single item changes, you must invalidate potential multiple cache entries, and that quickly becomes a maintenance headache. The more you cache, the more complexity you add. This is the trade-off that developers often underestimate. And if you decide to scale horizontally, that means running multiple instances of your application. And you need a distributed cache like Redis, for example, to synchronize the invalidations across all of those instances. Suddenly, your simple cache turns into a distributed system. Now you are dealing with latency, you are dealing with network partitions and distributed consistency. Welcome to the big league. The point is, caching can escalate in complexity much faster than you anticipate. Another problem: data consistency. Think about this scenario. You update your database. Then you remove the item from the cache. What if removing it from the cache fails and for some reason now your database and the cache are out of sync again? You might think, well, I will wrap it in a transaction, but what if your cache isn't transactional? Spoiler alert, most caches aren't transactional. So now you must decide, do you accept eventual consistency? Do you try compensating actions, for example, rolling back the database operation? Or do you implement transaction-like logic? None of these are perfect or simple. Every solution will bring complexity to the game. So, given all of these problems, how should you actually approach caching? Here's my honest advice. Start without caching. No cache at all. Keep it simple, measure your application performance, and find those spots where in fact you have a bottleneck. Cache carefully. Only cache when you clearly need it, like an expensive database call that rarely changes the data. Okay? Find those odd paths. Set sensible expiry dates. Even without a manual invalidation, setting short expiry dates like 5 or 10 minutes will help to avoid that stale data. Isolate your caching logic. Use patterns like decorators or dedicated caching services so that caching logic isn't spread across the code. Keep your concerns separate and easy to maintain. So let's be honest, caching isn't the perfect solution or a bad thing. It's one tool that we have in our toolbox, one more that we need to use considering all the trade offs. But caching poorly can do more harm than good, causing bugs, stale data, and developer frustration. We know it. The real secret to succeed with caching is to start simple. Measure always and add complexity when you need, when it's absolutely needed. And as you know, when we want to use a cache, we tend to use a key value store. So you want to watch this video right here, because there I will explain you how to pick the perfect key value store for your use case.